Let's take a look at doing the practice problems from Unit 6, Lesson 7. So this one asks about a point. So it says point 6 comma y is the same distance from 4, 1 as it is from the x-axis. What's the value of y? So remember in Lesson 7, we talked about parabolas. And so if we're talking about the x-axis, if we're talking about something that's the same distance from a line as it is from a point, then it's going to be on a parabola. So we'll look at this x-axis as the directrix. Okay, so here's the x-axis. It is also the line y equals 0. And then we've got the point 4, 1 as our focus. So the point 4, 1, and we'll just kind of sketch where that's going to end up. So here's 4, 1. And then 6y could be anywhere. We're not sure what the y value is, but I'm just going to sketch it out so that we can kind of draw and look at this. So let's just pretend it's there. And so again, this is the point 6y. So what we know about this point is that it should be the same distance from the focus as it is from the directrix. So we know that this distance down to the directrix, since the x-axis is the line the line y equals 0. So we know that this length right here is equal to y minus 0. So this right here is equal to y minus 0, or just y, meaning that this one would also be equal to that by definition, since it's on a parabola. So then what we want to do is use the Pythagorean theorem, and I'm just going to draw this off to the side here again so I can draw it a little bit larger. So here's my, let me draw the focus. Okay, so here's our focus. And then let's draw the other point that we're looking at. And again, I'm just going to draw it in a random spot, but we'll just label it. So this is the point 6y. And remember that this is the point 4, 1. And we know that this distance right here is equal to y, since this point is the same distance from the focus as it is from the y-axis, and it is y units above the y-axis. So we know that this is equal to y. So then let's go ahead and figure out the width here and the height and do the Pythagorean theorem. So we would be able to label this width by subtracting the x's. So 6 minus 4. So this length here is 2. And then this height here is going to be subtracting the y's. So y minus 1. And then that's all we can do for that one. So then we'll go ahead and plug this into the Pythagorean theorem. Okay, so we again know that c squared, which is y in this case, is equal to a squared, which is 2, plus b squared, which is y minus 1 squared. And now they actually want us to come up with the value for y. So we're going to go ahead and simplify some of this. So 2 squared is 4. We're going to multiply out this binomial. So we know that that will be y squared. We'll get 2 negative 1y's. So negative 2y for that middle term. And then negative 1 squared is 1. So let's solve this for y. So first of all, let's get our y squared over to the other side. So we'll subtract y squared, which will end up giving us 0, equals 4. And then y squared minus y squared is 0. So we have minus 2y plus 1. We can add the 4 and the 1 together. So we get 5 minus 2y. Then let's bring the 2y to the other side. So we end up with 2y is equal to 5. And then to solve for y, we would just divide both sides by 2. So we end up with our y value is equal to 2.5. Okay, then let's take a look at this next one. Again, number 2 talks about a parabola is defined by the set of all points the same distance from 6, 2, and the line y equals 4. So I just like to draw sketches of this so that I can kind of think about what's happening. And so we've got the line y equals 4. That would be our directrix. So this line at y equals 4. And then we've got the point 6, 2 as our focus. Okay, so 6, 2 is our focus. So all of these points that they give us, if they are on our parabola, they're the same distance from this y equals 4 line as they are from the point 6, 2. So figuring out how far they are from the directrix is just going to be subtracting, seeing how far the y value is apart. Okay. And so we can figure out what the distance needs to be just by subtracting those. So 4 minus a negative 2 is 6. So this point is 6 units away from the directrix. So now we would want to figure out how far it is from this point. And then if those distances are the same, then this is on the parabola. So remember to figure out how far it is from this point. Okay, so the distance squared would equal the horizontal movement. Okay, so subtract the x's. So 6 minus 1 squared. And then subtract the y's. So 2 minus a negative 2. And so 2 minus a negative 2 is 2 plus 2. So this would figure out, so you could plot the 0.1, negative 2 here. And so what we're doing is figuring out this slope triangle. So you're figuring out this distance by subtracting the x's. So that's that 6 minus 1. And this by subtracting the y's. And just doing Pythagorean theorem. So 6 minus 1 is 5. So we have 5 squared. 2 plus 2 is 4 squared. So this is 25 plus 16. So our d squared in this case is equal to 41. Which is, if we square root this, okay, this will be the square root of 41, which is not equal to 6. So the focus is, the point is a different distance from the directrix as it is from the focus. So this one is not on the line. So now we'll repeat and do the same thing with each of these points. So remember, figure out how far the point is from the y equals 4 line. So that's just looking at the difference between the y values. So the distance from the directrix is just 4 minus a negative 1, which is 5. Then we'll figure out how far this point is from the focus. So let me get rid of this stuff so we don't get lost in it. So now we're looking at the distance from the point 2, negative 1. So if you want, you can plot the point 2, negative 1. And again, you're going to find this horizontal and vertical distance and do Pythagorean theorem. So remember, this horizontal piece is going to subtract your x's. So 6 minus 2 squared. And then the vertical distance here is subtracting your y's. So 2 minus the negative 1. And minus negative 1 is plus 1. So this is going to be the distance for that. So the distance squared, we're doing Pythagorean theorem. And this needs to be 5 in order for this to be on the parabola. So 6 minus 2 is 4 squared. 2 plus 1 is 3 squared. So we get the distance squared equals 16 plus 9. 16 plus 9 is 25. And the square root of 25 is 5. So the distance from the focus and the directrix is the same. So point B is on the parabola. So we'll repeat again. So find the distance to the directrix. Remember, that's subtracting the y's. So the directrix y is 4 minus the points y is 2. So the distance from the point to the directrix is 2. Then we'll do the Pythagorean theorem here. Okay, so I'm just going to delete out this last one that we did. So this point actually, now if you plot it, the point is 6, 2. It's on the focus. So it is going to be 0 units from the focus. So this one is not going to happen. This is not 2 units from the focus. It is the focus. Okay, so this is not on your parabola. D, so we'll find the distance from the directrix. The directrix is 4 minus 3, okay, gives us a distance of 1. And then we'll figure out the distance from the focus. So remember, if you want, you can plot the 0.73 here. And this one you can probably tell is not going to be on. Well, it could be, I guess. The parabola goes through here. Okay, so this one, to find the horizontal distance again, subtract the x's. So 6 minus 7 squared. Find the vertical distance. So subtract the y's. 2 minus 3 squared. This distance needs to be 1. So 6 minus 7 is negative 1 squared. 2 minus 3 is negative 1 squared. So the negative 1 squared is 1. Negative 1 squared is 1. So your distance squared is 2 square root. And your distance is equal to the square root of 2, which is not the same as 1. So this is not on the parabola. Okay, one more time. So the distance to the directrix is the directrix y value minus the point's y value. So 4 minus 2 gives you 2. Then we're going to do the Pythagorean theorem to determine how far the points are from each other. So remember that hypotenuse squared, you need the horizontal distance, which is subtracting your x's. So 8 minus 6 squared. Then figure out the vertical distance, which is 2, subtracting the y's. So 2 minus 2 squared. So 8 minus 6 is 2 squared. 2 minus 2 is 0. 2 squared is 4, plus 0 is just 4. Square root this, and you get your distance is 2. That is the same as the distance to the directrix. So the distance to the point and the distance to the directrix are the same. So E is on your parabola. All right, number 3 asks you to compare and contrast 2 different parabolas. So parabola A is the points that are the same distance from the point 0, 4. So your focus is 0, 4. And the directrix is the x-axis. Now, again, I like to draw pictures of these. So I'm just going to draw a quick picture of parabola A. So the directrix is the x-axis. And the focus is the point 0, 4. Oops, let me make that pink. So then I know that the parabola would be drawn between these. Okay, so the parabola is going to be between these and facing upward since the focus is above the directrix. So this is parabola A. Then parabola B is the points that are the same distance from the point 0, -6, and the x-axis. So the x-axis is again the directrix. The focus is at the point 0, -6. So then our parabola would go through there. And so this parabola is going to open downward since the focus is below the directrix. And so this is parabola B. So comparing and contrasting these, some things that you can determine, they have the same directrix. Okay, they're both, the focus is both on the y-axis. Okay, so the focus in both is on the y-axis, meaning that it also has a line of symmetry at the y-axis. So this y-axis is a line of symmetry. So those are some things that they have in common. Some differences that they have, okay, is that A opens upward, B opens downward. So A opens up, B opens down. Also, this is the point 0.04. So it's 4 units from the directrix. Okay, and this one is 0, -6. So this one is 6 units from the directrix. So in A, since the focus is closer to the directrix, this one is narrower. Okay, so this curve is narrower and B's curve is wider. So those are just a few things. Find the center and the radius of this circle. So first thing we'll do is rearrange the terms to get them next to each other. So we only have an x squared term. We don't have just an x term, so we'll write that one by itself. We've then got the y squared and the -8y that we're going to have to complete the square with. And then we'll subtract this 5 to both sides to bring it over to the other side. So we have this -5. And then we're going to need to make sure that we add this, whatever we use to complete the square here. So this part's already done. Okay, we've got our perfect square here, just x squared. If you want to think of it as x minus 0, you certainly could. So let's complete the square with the y part. And so we will divide this middle term by 2. So -8 divided by 2 gives us -4. -4 squared gives us 16, which we would want to make sure we add to both sides. So then we factored kind of at the same time. And then -5 plus 16 is 11. So then our center here, the x coordinate of the center is 0. The y coordinate of the center is 4. And then our radius, so our r squared is 11. So then we will square root that to get our r. So our radius is square root of 11. All right, match the equation, match the expression with what would make it a perfect square trinomial. So we'll divide the middle term by 2 and then square it. So 14 divided by 2 is 7. 7 times 7 is 49. So A matches with number 2. I'm going to skip that one for a second, see if there's anything easier. Okay, I see an easier one here of -10. So -10 divided by 2 is -5. Squared is 25. So C goes with number 3. Okay, then we can tackle this bottom one is a 1. So 1 divided by 2 equals 1/2. And then 1/2 squared. So think of 1/2 squared as 1/2 times 1/2. 1 times 1 is 1. 2 times 2 is 4. So 1/4 for this one. So number 4 goes with D. And then we can look at B. So we have -1/2 divided by 2. So if you think of half of a half, that's going to be a fourth. So -1/4. The other way you can think of dividing. So when you divide by a number, it's the same as multiplying by its reciprocal. So we'll change the multiplying by a half instead. And then you see the -1/4 happen that way as well. And then we would square it. So again, think of squaring as multiplying by itself. So -1 times -1 is 1. 4 times 4 is 16. And that's where we get number 1 for 1/16 for that one. All right, write each expression as a binomial squared. So this is just factoring it down. So making sure that the middle number divided by 2, which is -6. Making sure that -6 squared is actually 36. Okay, and it is. So this would be the factored version. Divide the middle term by 2. Okay, and this is +8 divided by 2, so it's going to be a +4 here. 4 squared is 16, so that's good. W, so take -16 divided by 2, that's -8. -8 squared is +64. Number 7, write an equation of a circle that's centered at -1,4 with a radius of 10. So remember the circle equation is x minus h squared plus y minus k squared equals our radius squared. Okay, and h and k are the x and the y coordinate from the center. So we do x minus the x coordinate of the center, so x minus 1. Y minus the y coordinate of -4. And then the radius squared. So that's the equation. You can just clean it up a little bit, leaving x minus 1 squared, but y minus a -4, you could write as y plus 4 squared, and then 10 squared as 100. Number 8 talks about density. So remember that density equals mass divided by volume. And if the density is bigger than 1, the object sinks. And if it's less than 1, it floats. So will a solid bar of soap shaped like a rectangular prism, because we're going to need volume, okay, and volume of a rectangular prism is area of the base times the height, with a mass of 1.048. So here's the mass. So we automatically know the mass. They just give that to us. With dimensions, okay, remember it's a rectangular prism, so the dimensions, length, width, and height. Will it float or sink? So area of the base, we would just multiply the length by the width. And then the height of the prism is the third measurement. So 5.6 times 13 gives us that base area of 72.8. And then we'll multiply these together to get the volume. So the volume equals area of the base times the height, which is 1,164.8 centimeters cubed. So this is your volume. So this will go in here. And then we would divide those. And the density of that soap bar is equal to 0.000899, which is way less than 1. So that is going to float. If it's less than 1, it floats. And this is way less than 1. All right, Jada has an idea for bisecting an angle for constructions. So first thing she did was she drew a circle that is centered at B, and she drew it to go to A. Then she labeled the other point that it intersected, or she then connected B through C. That was the angle. So where it crossed the angle is D. So where it crossed the original angle that she had. So here's the original angle. Labeled that point as D. And then she created the perpendicular bisector. So then she constructed the perpendicular bisector through the segment that connected A and D. Will this bisect this angle is the question. Okay, did her construction work? So if we take a look at the idea of a perpendicular bisector, remember perpendicular bisector means that this is a 90-degree angle. Bisector means that these two pieces are congruent. And then we also know that this segment here is congruent to itself. So the two triangles here, okay, these two triangles here are congruent. So let me just name this point right here, M. So triangle ABM is congruent to triangle BDM, biside angle side. So since the triangles are congruent, then these two angles would have to be congruent. So angle ABM would have to be congruent to angle DBM because they're corresponding parts of congruent triangles. So we just proved the triangles were congruent and those are corresponding parts. So they have to be equal. So then BM, okay, ray BM would be a bisector, okay, is an angle bisector by definition because it splits that angle in half. So yes, it works for her to draw a circle, connect it, mark the intersection as D, and then make the perpendicular bisector.